Hi everyone. In today's lesson, we're going to talk about how to create tangent and normal lines. So let's just start with a basic example. So the graph below is of this quadratic function. The derivative equation is given as f prime of x equals negative 2x minus 2. So first things first, what is the equation of the derivative and what does this help us find? Well, first we have to analyze the two pieces that they give us. They give us f of x, which is our original function, and then they give us our f prime of x, which is our derivative. So I need you to understand that f prime of x is my derivative notation. So this means derivative. So the first part of the question is, what is the derivative equation? And we can say f prime of x is negative 2x minus 2. And what does this help us find? This helps us find the slope of the tangent line at any x value. So what is the slope of the tangent line at x equals negative 2? Well, we just said that this derivative equation helps us find the slope of the tangent line at any given x value. So what we can do is we can start by writing the derivative equation, and we're simply going to substitute negative 2. Notice the notation, f prime of negative 2 means everywhere I see an x, I'm going to put in a negative 2. So f prime of negative 2 equals, what's this, positive 4 minus 2 is 2. So what we just found is the slope of the tangent line at x equals negative 2, right? Slope of the tangent line at x equals negative 2. So the m value, my slope, is 2, right? Part C, what is the equation of the tangent line at x equals negative 2? So the equation of a line, right, tangent line, there are two forms that we can use. The first form that you're probably used to is y equals mx plus b. Now, we could use that, but we're going to use this formula instead. This is called point slope form of a line. So we could write maybe on the side that this is called point slope form. And it gets its name because in order to use it, we need a slope, which we'll call m, and we need a point, which we'll call x1, y1. And usually the x and the y stay alone. So we need two things when making up the equation of a line. We need a point and a slope. So the point we get when we analyze the original equation f of x. And we get the slope when we analyze the derivative, f prime of x, all of which at x equals the value that we care about, which here says negative 2. So f of x at x equals negative 2, and the slope, f prime of x at x equals negative 2. Best way to remember this, derivative means slope, right? Didn't we say the derivative equation gives us the slope of the tangent line? So when we want to find the slope, we're going to use the derivative equation. When we want to find the point, we use our original function f of x. So our original function for f of x is negative x squared minus 2x plus 3. And I want to find the y value, so I'm just going to plug in my x value of negative 2. So let's do some math quick. This gives me 4, then a negative in front is negative 4, plus 4 gives me 0, and then plus 3 gives me 3. So what you just found is that when I plug in x to be negative 2, I get out y value of 3. So this corresponds to a point, negative 2 for x, 3 for y. And this becomes my x1 and my y1. Then we're going to use my derivative equation, f prime of x, which was given to us, negative 2x minus 2. And we're going to do the same thing, but this time we're going to plug in negative 2 into my derivative equation. So -2, -2, -2. And we did this before, I'm just writing it all out. 4 minus 2 is 2. So this slope, m value, gives me 2. And all we're going to do now is just put it into the equation here. So y minus y1. So y minus my y1, which is 3, equals m, which is 2. And then x minus my x1, which is -2. So that double negative will make this +2. And this is the equation in point slope form of my tangent line. Okay, let's take a look at what we did here graphically. So to find the point, we found it's -2, 3. So let's verify with the graph. So when x is -2, y is 3. Yes, it is. So -2, 3. And I want to find the equation of the line tangent to this. So tangent, I'm just going to draw a sketch. This line isn't going to be perfect. Should look something like this. Now my graph looks like it's hitting twice, but it really should only hit once. So that is the equation of your tangent line. And that will definitely have a slope of 2. And this is the equation of that line. So visually, that's what you're doing. You're writing the equation of this line that passes through this point. Okay, part D. What is the equation of the normal line at x equals -2? So this is here a new definition. A normal line is a line that is perpendicular. That's the symbol for perpendicular. Perpendicular to the tangent line. And we should know that perpendicular lines meet at 90-degree angles. So if I were to just draw a representation of this, a normal line would be a line that goes through that same point, but that intersects the tangent line at 90 degrees. So you can go ahead and label this one with the words normal line. So again, a normal line intersects the tangent line at 90 degrees, but it will also go through this same point. So that since the point's the same, the x1 and y1 are going to be the same. So we can go ahead and start and plug in. So first y minus y1 equals m x minus x1. So we said the point was the same, which is -2, 3. Now the slope is actually not going to be the same. The slope is not going to be 2. The slope is going to be -1/2. And the reason why is we have to take a page out of the geometry textbook and we have to understand that perpendicular lines have negative reciprocal slopes. So if the slope of the tangent line is 2, the negative reciprocal, negative and flip, would give me -1/2. So pretty much everything is the same. The y1 and the x1 is the same. We just have to switch and negate the slope. So here's your x1, y1. So y minus 3 equals now -1/2 x minus -2, which changes to a +2. And that is the equation of my normal line. Okay, so we took some great notes here. We took some notes just to recap on what a derivative equation is, what it helps us find. We found the slope of the tangent line. We found the equation of the tangent line. And we found the equation of the normal line. And we also showed a visual representation of this. So what I would love for you guys to do right now is take a look at example number 2. So it's a square root example, and that's okay. Here's a picture of what it looks like. I would love for you guys to try to do all parts of this for homework, and then we will reconvene tomorrow in class by going over this first. All right, do the best you can on this, and have a good night.